Now, question number 3. The equation of the function g of x passes through the point 3 and 2 and has a range of y is an element of negative infinity to 1, union of 1 to a positive infinity. And then the first question, determine the equation of g. So g is our hyperbola, right? And x is not defined when, or rather g is not defined when x is equals to 0. And with hyperbola graphs, I'm expecting to have two asymptotes, one being the horizontal asymptote and then the other one being the vertical asymptote. And the vertical asymptote is defined, we normally look at our denominator and then we say x, okay, in this case we've got 0, so x plus 0 is equals to 0. That means our vertical asymptote, it's x is equals to 0, right? And then the horizontal asymptote is defined by our q value. What we normally say y is equals to q. And we are given additional information there. We are told where this function of g is defined for our y values. So notice that this function is defined everywhere except when x is, no, not x, except when y is equals to 1. So when our y is equals to 1, this function is not defined. So therefore our value of q, it's the value 1. So I can rewrite this as, we'll say our horizontal asymptote is y is equals to 1. Okay. Yeah, and then with our vertical asymptote, I just went straight ahead and said x plus 0 because we are not given any other information. We are not given like a restriction, just like this one, whereby we are told that x is an element of this and that. So hence I just assume that this should give us our vertical asymptote. But in the event that you are given like something like this, where you are told that x is an element of negative infinity up until, let's say, negative 3, and then union of something like negative 3 up until positive, so that should tell you that your vertical asymptote is the x value. So you will have something like x plus 3 equals to 0, which tells you that whenever this function is at x is equals to a negative 3, is not defined. However, in this case we don't have that, so hence I just went straight to this to say x plus 0. So now we've got enough information to start to at least determine what our g is. I can rewrite my function as y is equals to 8 divided by x, then plus 1, and then I will use this point to substitute into this equation and find my value of a. So for y I've got 2, and then for x I have the value 3 plus 1. And to simplify this, I'll transpose 1 to the other side. I'll have 2 minus 1, which will be just 1. 8 divided by 3, and then I will cross multiply everything by 3. Okay, I'll just cross multiply. I will therefore have a is equals to the value 3. Which means our function of g of x is defined by 3 divided by x plus 1. And then now the second question, determine the equation of h, the axis of symmetry of g, which has a positive gradient. Okay. I will take my asymptotes. I have asymptote x is equals to 0, and then I have y is equals to 1. So I've got 0 and 1. And my original axis of symmetry with a positive gradient, it's defined by the line y is equals to x, right? However, for this function, obviously it has been shifted, so therefore this new axis of symmetry is defined by my positive gradient x minus 0 then plus 1. Therefore h at x is defined by x plus 1. So that is the axis of symmetry with a positive gradient. And then now the second question, sketch the graphs of G and H on the same system of axes. Clearly show all the asymptotes and intercepts with the axis. Okay, before I do the sketching, let me first find my x and y intercepts for the function of G and find the x and y intercepts for the function of H. Okay, the function H is the easiest, so let me begin with H. Okay, let me make space here. Let's move or delete. Let me delete once. So let's find the x-intercept for the function of H, or the axis of symmetry. So I'll let my y is equals to 0. So I have 0 is equals to x plus 1. This is just x is equals to a negative 1. So for the x-intercept, it's when x is negative 1 and 0. And then the y-intercepts of H, I will let x is equals to 0. So I have y is equals to 0 plus 1. This is just y is equals to 1. So whenever we've got 0 and 1, we have an intercept. And this is for h at x. And now for the function g of x, our x-intercepts, I will let y is equals to 0. So I've got 0 is equals to 3 divided by x plus 1. I'll have negative 1 is equals to 3 divided by x. So I will cross multiply. I will have x is equals to a negative 3. So whenever we've got negative 3 and 0, there's an intercept there. And then for the y-intercept, for this function, we cannot have a y-intercept, right? Because if ever I were to say let x is equal to 0, I'm dividing by 0, which makes this thing undefined. And another thing that we need to remember is that we said our vertical asymptote is the line x is equals to 0, of which that line is directly on top of the y-axis. So hence we cannot have an intercept on our y-axis, because the y-axis is also the asymptote. So hence for the y-intercept, I'll just say it's undefined, even though this is not needed. Yeah, like showing it's undefined, but it's just for good practice. And then now I've got enough information to start doing my plots. So I'll just do a quick Cartesian plane here. Let's say this is our x-axis with a black pen, right? And then we have the y-intercept. Oh, the y-axis. And this is not drawn according to scale, so. And then my asymptotes, I've got the line y is equals to 1, which should be somewhere there. And let's give that a red color. And then the vertical asymptote, which is the line x is equals to 0. It's directly on top of the y-axis, so the asymptote is on top of the y-axis there. And then the x-intercept of G is at negative 3 and 0. So let's say negative 3, it's let's say negative 1, 2, 3. Let's say it's somewhere there. Oh, and another thing that I forgot to mention, since our value of a is greater than 0, meaning it's positive. Therefore, this function of g will be drawn on the first and third quadrant. So I'm expecting my function to be here and there, just by looking at my value of a is greater than 0. And getting this x-intercept in this quadrant is a clear indicator that, okay, yeah, indeed, we are on the right path. So my function should look like, it should go that way, and then the other part should move down to negative infinity. And let's say that's negative 3. And then the other part of our function of g should be on this quadrant, and we have no intercept there. Yeah, surely you can draw a better curve than me, hey? And then our axis of symmetry intercepts at -1 and 0. So if that's -3, let's say -1 is somewhere there, and then 0 and 1, that's exactly where our two asymptotes intersect. And that means our axis of symmetry with a positive gradient moves like that. So even though this diagram is not according to scale, it looks almost good, hey? So I can now begin to name my points. That's -1, and that's a +1. And this is our function of g, and then this is our axis of symmetry h. And then that's the line y is equals to 1. That's the x-axis and then y-axis. So this should be our function of g and h. And then the last question, write down the equations of the asymptotes of f if f of x is equals to -g of x plus 5. So now they created a new function f of x, right? And what they did, they multiplied the function of g by -1. So I'll just multiply g by -1. I will have -3 divided by x minus 1. Then I add 5 plus 5. And then the f of x is defined by -3 divided by x. This is plus 4. And then now our equations of the asymptotes, I just look at my q value for the horizontal asymptote. So I'll have y is equals to a +4. And then for the vertical asymptote, I look at my denominator. It's just x plus 0 is equals to 0. X is equals to 0. So these are our equations of the asymptotes. Y is 4, x is equals to 0.